Hello everyone, welcome back. Now let's see how to fit our model. In the previous lecture, we defined the code of our linear model or linear regression, loss function and the gradient descent. Now let's see how to fit the model in the TensorFlow and also define the epochs here. So before that, let's create some function of the plot, scatter plot, because I just want to execute and at the same time in each and every loop I just want to see how my graph, how my model is learning in visually. So for such case I just want to do the scatter plot here. So let's say I'm having the two inputs with me, and what I have to do is that plt dot scatter. I'm getting the scatter plot of x and y, and also I need to find the plot between x as well as that model of x. So this is what I just want to find in our case. Model of x is what the predicted value, and this is the plot of this. This is my linear regression. Basically, this is the line, and this is my scatter plot. So what I will do, let me do one thing. Let me draw a line, red line. So let's see how exactly I'm getting properly or not. And we need to specify x and y values, and so this is what my blue one is actually the original values, and initially this is the initial model. Initially it is a red line. Obviously that's the case. Initially our model is not trained, and the values of model dot a, and for the intercept, the initial intercept and the slope of the line is 0. So that's why we got the straight line with the horizontal line, and the initial value is 0 and slope of the line is 0. So we will try to find out the best fit line in our case. Okay, so first thing is first, let's do it again. Let's define the model again, even though we defined that, but it's fine. Let's define our model again. So model is equal to regression, and also let's say I just want to store all my a values in a list, and similarly I want to store all my slopes or nothing but the b values in a list, and I just also store my cost function, cost values in a list, and everything. So what I want to do is that let me define the epochs here. Epochs are number of steps that I want to execute here. So let's say initially I will consider like epochs is equal to 20. Also I will define the learning rate. Let me also define the learning rate here. So initially I will set the learning rate is as small as possible. So learning rate, let me specify like 0.001. It's a very small learning rate, but still it is fine for me. So let's see whether it is working fine or not. Otherwise I will change the learning rate in this process. Okay, I define that. Now let's run the loop and run our model for epoch and epochs. So first thing is that let me save all the values, each and every epoch dot append, and what I'll need to save is that model dot a. Similarly, a underscore values dot append, let me save the values is model dot b. Append model dot b, and also let's save the cost values. Cost values is okay. For that I need to get the cost value. First of all, cost value is the loss function, which is y. In my loss function I have to give the true values. The true value is y, and the predicted values is what I need to define here. So let's define the predicted values is equal to model of x is what my predicted value. This is the predicted values and error function, which I will do in this case. So I got the cost function and I got the predicted values. So let's save it here. So cost underscore values dot append, and this is my cost value. So I got cost function, I got the cost values, and so on. So this is all this I just want to save in the list. We will see and visualize in the later on in the section. Okay, fine. Okay, we got all the values here, And the next thing I just want to do is that training. So training is simple, is that you need to call this function train. So that is the function I need to train in this case. So what we need is that model. Okay, I need to, since the model is already there, and inputs is x, output is small y, and the learning rate is the learning rate. Learning rate is the learning rate. Cool, I got all the values now. So what I will do now is that let me visualize the models, visualize the scatter plot and model performance. So let's say, like, since we already defined the function pl plot underscore scatter, let's run this plot underscore scatter. So the input is x, and this is what the output I'm getting here. And next is print the values. So for printing the values, print the first thing, I'll print the epoch. So this is the particular value of epoch, and that is what my percentile, which is my percentile d. And also I just want to look into my loss function. I'll just look into my float values, percentile 0.2 f, and that's it. That is enough. So if you want, you can also specify the model values a as slope as well as intercept. Let me specify a. So a is what the float value 0 percentile 0.2 f, and similarly my slope is percentile 0.2 f. So we got those values now. Yeah, let's do one thing. Let's put it here. Now the values are epoch, and the loss function, in this case it is my cost value is what my loss function, and intercept, it is the intercept a values, which is nothing but my last value here. And similarly a underscore b values, b in the similar my slope is b underscore last value. So hope everything is fine now. Let's see, check once again, is there any errors are there or not. Okay, seems to be fine. Let me execute this. Okay, I got an error. Yes, epochs is range. I need to specify the range here, range of epochs. And let me do one thing. Let me also specify, like, plt.show. Let's execute that. Oh, we got an error saying that was expected 64-bit tensor, and but the float tensor is what we got. Invalid argument error. Okay, that is 60, but I specify everything is the float values. So let me check my models, like initial value tf.32, float 32, and convert into tensors. I need to do that, and obviously I'm not doing anything, and this is the true value. Yeah, here I think we need to change the data type to tf.float32. I just want to change the data type over there, and anything predictions, obviously we get the tensor values and so on. Yeah, let's execute this again, train, and let's execute this function again. Oh, hope, yeah, we got the results. We got the results, and as you can see, the first thing is that our model is getting highly unstable in this case. So let's do one thing. Let me remove this. Let's comment this plot, and let's visualize it again. And for each and every iteration, my model is getting unstable. So obviously that's the case because the independent variables and the dependent variables are not maintained in the same scale. The scale of my x is in the range of 0 to 25, and the scale of y in the range of 0 to 120. Since both are in not the same scale, obviously you might get an error. So the solution for that case is that normalizing your data. Data normalization, either apply the z-score or you can apply the min-max scaling to bring that into the same scale. That is the one part. Or since what I found in this case is that the data is only two variables. So, and also the change in values is approximately 4 times, and still we can achieve that by changing the learning rate. So the learning rate is the key here. Means each and every step there are a lot of changes are there. That's what it means, that as you can see, even from the results what you're getting, the loss is increasing, but actually you can see that the slope is very high in the first epoch, and it is decreases, increases, decreases, increases. So it says that there is nothing problem with our logic. Only the problem is that our slope, and all the same time our loss function is what the learning rate is the problem here. Since the learning rate, it seems to, let's control the learning rate by just change the learning rate as small as possible to 0.00001, and let's change the learning rate and let's check that. And now you can see that the values are keep on decreasing in our case. Let's see how exactly we able to get in this case. Now you can see that initially we start with a small value, and as the learning rate increases, slowly we can able to achieve the good results. So let's increase the learning rate a bit, and instead of 20, I'll just take it as 100 epochs, and let's see how our model is performing. And you can see that slowly our curve is getting better and better and better. So this is one of the powerful approach of the gradient descent algorithm, which will make you to solve any kind of problems like this. So this is how you can able to solve any problems and all. And let's make it for 200 iterations, and let's check it again how it is working. And as you can see how our data is changing. Okay, cool. You can see that how we able to getting the stable values, and let's plot our different values. So first thing is that my cost values. You can plot the cost values with respect to epochs, and this is my plt dot plot the cost values with respect to epochs. You can see that for the 200 epochs how my cost value is changing. So this is what we got from the cost function. As you can see, my loss is coming down at a certain point, and after 100 iterations it is maintaining the constant. It means we can able to achieve our equilibrium point with this case. So this is how we can able to train our model, and you can also able to train our custom model using the advanced techniques, the TensorFlow. So this is what we achieve. Finally, one thing I'm saying, we have the input which we did the simple model y is equal to a plus b into x. We need to find out what is the value of a and b. For that you need to get the best values. And the thing is that we go first, for that we need to compute the cost function, calculate the gradient, and update all the values. This is what we did initially. We have the 0 value of a and 0 value of b, and slowly we can able to achieve the best values of a and b. So by the end of this model you can see that after 200 iterations, the value what you can see is that the intercept is 0.13 and the slope is 2.89, which is what the best values of a and b. Hope you enjoy this module. Thank you very much.